In this video, I'm going to be working Algebra 2 Homework 8.1. We're going to be doing a lot of simplifying radical expressions. And so there's going to be a lot of, putting things in simplified radical form. That's not at the beginning, but just to remind you, that's where we're going to be having no unreduced radicals and no radicals in the denominator. Okay, so we're going to start with some fraction exponents, though. So 64 to the 5/6. Okay, remember, I'm going to recommend that you deal with the denominator of the fraction first, right? And so the 1/6 power is the 6th root. So this is the 6th root of 64, so maybe a little too zoomed in, taken to the 5th power. Okay. And the 6th root of 64 is 2 to the 6th, so the 6th root of 64 would be 2. Taken to the 5th power, that's going to be 32. Okay. If you needed to, you could say, okay, that's 2 times 2 times 2 times 2 times 2, and do, kind of work it out, 2, 4, 8, 16, 32. Okay, but hopefully at this point, we've been doing a lot of powers of numbers, and you might just know that 2 to the 5 is 32. The second one's 27 to the 2/3 power. Okay, so we're going to start with the denominator of the fraction and make that the root. So that's the 3rd root of 27 squared. Okay, 2/3 power. Okay, the 3rd root of 27 is going to be 3. Okay, we're going to square that, and we'll get 9. Alright, negative 8 to the 4/3 power. We're going to start with the denominator, so it's the cubed root of negative 8. And remember, it's fine to take the cubed root of a negative number, it's just going to come back negative. And then we're going to take that to the 4th power. A number whose cube is negative 8, that would be negative 2. If I take negative 2 to the 4th power, you could look at that as negative 1 to the 4th power times 2 to the 4th power. Or you could just know, okay, if I have negative 2 4 times, I'm going to have 4 negatives, and that's going to end up being positive. It's really the same thing. So it's going to be positive 16. Alright, 216 to the 2/3. Well, I'm going to start with the cube root of 216. And then I'm going to square that. Okay, now the cube root of 216, I think that's going to be 6. Because if I did 36 times 3, that would be 90 plus 18. No, 36 times 6. That would be 180 plus 36. Yeah, that's 216. Okay, yeah, so the cube root is 6. And I'm going to square that, and I'll get 36. Okay. The next one's got a negative exponent. We haven't dealt with that in a while. Okay, so I'm glad we're seeing that. So what I'm going to do is I'm going to just say that's 1,000 to the 2/3 to the negative 1st power. I'm going to deal with that at the end. Okay, 1,000 to the 2/3. I'm going to have to, work with the thirds first. That's the cube root of 1,000 squared, then taken to the negative 1st power. And the cube root of 1,000 is going to be 10. And then I square that and take that to the negative 1 power. Let's see, oh, no, not enough room. Okay, so 10 squared is going to be 100. 100 to the negative 1 is 1 over 100. Alright, now this one, okay, we've got 16x squared taken to the 3/2 power. We're going to have to take 16 to the 3/2 and multiply that by x squared to the 3/2. And over here where we've got x squared to the 3/2, that's where we're going to just multiply the exponents. So 2 times 3/2, that's going to be 6/2, that'll be 3. And then 16 to the 3/2 is going to be the square root of 16 taken to the 3rd power. And the square root of 16 is 4, and 4 to the 3 is 64, so I've got 64x to the 3. Now we're going to just write the expression as like a fraction exponent. Okay, so this one where it's x to the 4th, the 5th root of x to the 4th, we're going to say that's x to the 4 over 5 power. Remember, the index of the radical is always what ends up being the denominator of the fraction. So we're going to keep going over here. The square root of 169 taken to the third. Well, square root, that's the second root. So the denominator of my fraction exponent will be 2. And then the numerator will be 3 because I'm taking that to the third power. Okay, 36 to the 14th, 7th root. Okay, so that would be 36 to the 14, whoops. Taken to the 1/7 power, right? Because the 7th root is the 1/7 power. And just showing you another reason why this works, this is where I would multiply the exponents, and that would be the 14 divided by 7 power. And that's just, okay, well that's just the half power. Oh. That looks like a different page. So I'm saying that's 36 to the 14 over 7, or you could just say that's 36 squared. Okay. 3 to the 4th, 5th roots, that would be 3 to the 4th fifths. This will be negative 6 to the 3/5, and this will be 30 to the negative 3/4, right? The index of the radical is always becoming the denominator of your fraction exponent. Alright, now simplify the expression. Oh, I like that with a warning. If you use a calculator on these, you will probably not be prepared for the quiz next time. Okay, we're going to assume that all variables are positive, but unless you're just like looking for trouble, that's not a huge deal. What we need to remember is, I guess, our radical properties here is that this is going to be the cubed root of 125 times the cubed root of x to the 9. And the cubed root of 125, that's going to be 5. And the cubed root of x to the 9, well, that would be like x to the 9 taken to the 1/3 power. I can multiply those exponents. 9 times the third is 3. Or you could look at the cubed root as dividing the exponent of something by 3. Either way, you're going to get x to the 3 power multiplied by 5. Okay. With b, okay, we can split a radical over multiplication or division, just not addition or subtraction. Notice how there's not ever anything, added or subtracted inside the radical in these problems. 4th root of 81. Well, if you're tasked with taking the 4th root of a number and you're not totally sure what it is, the 4th root is just the square root of the square root, right? So you could just say that this is the square root of the square root of 81. Okay, the square root of 81 is 9. And the square root of 9 is 3. And the 4th root of x to the 8, the 4th root divides the power by 4, so it'll be x squared divided by 3. C is going to be the cube root of 64. Actually, hold on. I'm going to simplify. So one thing we could do is we could actually divide the 64 divided by 8 before taking the cube root. I think that might actually be helpful for us. So I'm going to take the cube root of 8x cubed. Yeah, that'll be way better. And then I'll be taking the cube root of 8 times the cube root of x to the 3. And the cube root of 8 is going to be 2, and the cube root of x to the 3 is just going to be x to the first. Oh, yeah, there's a lot of these. So, alright, 4 to the 3 halves times 4 to the 5 halves. That's where we're going to add the exponents. So that's 4 to the 3 halves plus 5 halves is equal to 4 to the 8 halves, which would be 4 to the 4. And, oh, goodness. Okay, so 4 is 2 squared. Okay, so if we have to do this without a calculator, this might be a little bit on the boundary of the arithmetic I would ask you to do in Algebra 2, but it is arithmetic that we do see in AP Calculus, like these higher powers of 2. So what I'm going to do is I'm just going to show you that this is 2 to the 8th, and then it's going to be 2, I'm going to write them all out. Yeah, I think that was 8, yeah. 2, 4, 8, 16, 32, 64, 128, and 256. Okay, so it's going to be like that. Alright, this next one, okay, we're dividing two things with the same base and different exponents, so we're going to subtract those exponents. It's going to be 27 to the 2/3. So I'm going to take the cubed root of 27, and then I'm going to square it. That's going to be 3 squared is equal to 9. Okay. I might, work with the exponents first here. So if I'm taking power of a power, that's where I'll multiply the exponents. So 2/3 of a half, I'm going to multiply 2 divided by 6, that's like 1/3. 125 to the 1/3 power, that's the cube root of 125, and that'll be 5. Alright, this one. I like this letter G here. This is a good example of why, we need to be strategic. I don't expect anybody to know what 27 times 64 is in my class, in any of my classes. Okay, that's too much for arithmetic. What we're going to do instead is we're going to kind of like reduce both of these things and then multiply them so that we can keep the arithmetic manageable for ourselves. So I'm going to say this is 27 to the 2/3 times 64 to the 2/3. And then I'm going to say, all right, deal with the thirds first, right? The denominator, so it's the cube root of 27 squared times the cube root of 64 squared. And the cube root of 27 is 3. 3 squared times the cube root of 64 is 4 squared. Now at this point you could say, all right, well this is going to be 9 times 16. And that's going to be 144, but I don't just exactly know 9 times 16 is 144 off the top of my head. The way I really knew this was I was thinking, oh wait, I could go back and say that's 3 times 4 squared, and I know that 12 squared is 144. So it's, at that point, however you like it. Alright, now we've got negative 27 to the 4/3, so that would be the cube root of negative 27 taken to the 4th power. The cube root of negative 27 is going to be negative 3, because if I took negative 3 to the 3rd power, I'd get negative 27. And so that's negative 3 to the 4, that's negative 1 to the 4 times 3 to the 4, and negative 1 to the 4 will be positive 1, because an even number of negatives. And then 3 to the 4 is going to be 9 times 9 is positive 81. 64 to the negative 3rd, I'm going to say that's 64 to the 1/3 to the negative 1st power. Because it's been a while, I'm just really emphasizing the negative 1 power, takes whatever we have and flips it and makes a fraction. And we'll do that at the very end. Okay, 64 to the 1/3 is the cube root of 64, which is going to be equal to 4. And 4 to the negative 1, well, that's 1/4. 13 to the negative 2 is 13 squared to the negative 1. And 13 squared is 169. And so 169 to the negative 1 power is 1 over 169. Alright. Now this one, alright, this one's got a little bit of trickiness to it because we got the parentheses on top, but no parentheses on bottom. So what we're going to need to do is we're going to need to take both the 25 and the x to the 3/2 power, but in the denominator, only the x will be taken to the 1/2 power, right? Because exponents before multiplication by 5. It's just parentheses takes precedent over any of these things. That's why P is the beginning of PEMDAS. So it's going to be 25 to the 3/2 times x to the 3/2 divided by 5 and an x to the 1/2. I think I might work with this 25 to the 3/2 right now. 25 to the 3/2, I'd take the square root of 25 and then cube that. Okay. But the square root of 25 is 5, and I've got that 5 to cancel with, so maybe I'll just write it as 5 3 times. And then x to the 3/2 minus 1/2, because I'm dividing two things with the same base in different exponents. And I'm still dividing by that last 5 over here. Alright, so then I could cancel one of these. I'd have 25x to the 2/2, so that's just 25x to the 1st. Alright, with these two things, since they're kind of different enough and getting taken to different exponents, I think I'm going to just work with, the 4x thing and the 9x thing separately, and then combine them at the end. But I'm sure there's, a different way you could do that. Maybe just distribute all the exponents, rearrange stuff, because it's all multiplied together. It's however you think. So I'm going to say this is 4 to the negative 1/2 times x to the negative 1/2 times 9 to the positive 1/2 times x to the positive 1/2. And then, Okay, 4 to the negative 1/2 is the square root of 4 to the negative 1 power. 9 to the 1/2 is just the square root of 9, and then I'll just put the x's together. Because we can, if we're just multiplying a bunch of things together, we can multiply in whatever order we like. So the square root of 4 to the negative 1 would be 2 to the negative 1 times 3 times x to the negative half times x to the positive 1/2. We'd add those exponents, we get x to the 0. And x to the 0 is going to be 1, provided that x isn't 0. But they said at the beginning to not worry about, the variables were 0 or negative. So we won't. We'll just say x to the 0 is going to be 1. 2 to the negative 1 is 1/2, so I've got a half times 3 is 3 divided by 2. 169 to the negative 1/2 is going to be the square root of 169 for the half power to the negative first power for that negativity there. Okay, and the square root of 169 is 13, and 13 to the negative 1 is 1 over 13. All right, remember the negative exponent doesn't make the number negative, it just makes it a fraction. All right, just keeps going. So n is going to be the fourth root of a bunch of stuff altogether. So I'm just going to kind of say it's the fourth root of each of these things separately. We've already done the fourth root of 81 once in this worksheet, so I think I'm just going to say that's 3. In the denominator, the fourth root of x to the 16, we're just going to divide the exponent by 4. And same with y to the 8. If it's the fourth root of y to the 8, we're just going to divide that exponent by 2. And I'd have x to the 4, y to the 2, all divided by 3. Alright. This one's tricky. So negative 81 to the negative 5/4. So what I'm going to do is I'm going to start with the denominator, like always, and make that the index of my radical. So I'm going to have the fourth root of negative 81, then taken to the fifth power. That would be negative 81 to the 5/4. Then it's negative 5/4. Okay, that's the negative first power. Okay, the problem is that fourth root of negative 81. That's like the square root of the square root. And so I think, before the last unit, we would have said, wait, this doesn't exist. This isn't a real number. No solution. I'm just going to remind you that now, I guess because it's the fourth root, there's a little bit more to it than just saying that it's going to be 3i. But I think in this course, I'm just going to say, yeah, that the fourth root of 81 is going to be... Let me think about this for a second. Yeah, pardon me. We're going to not be able to go any farther with this because the fourth root of 81, it just requires a little bit more than we have in the realm of imaginary numbers. What I'm going to say is that I to the 4 is equal to positive 1. So we don't really have a fourth root of negative 1. Just in case you were curious, I might just off to the side sneak it over to you. If you were curious, that's the fourth root of negative 1, or one of 4 fourth roots of negative 1 over the complex plane, but we're not going to worry about this. We're going to say that this is not a real number, and it's not going to be a number that's going to be easy for us to find. It's complex, but we're not going to be able to find it very easily, so we're just going to leave it at that. Alright, we've got a whole other page of these, so let's just get to it then. Alright, if I'm taking the fourth root of something to the 8th power, I'm going to divide that thing's exponent by 4, so this is going to be 2x squared multiplied, and same thing with taking the cube root of something to the 6th, that's just going to divide its exponent by 3, so 6 divided by 3, that's 2. So if I've got 2x squared times 2x squared again, I'd have 4 total powers of 2x, and then I would, take each of these things to the 4th power. And this only works over multiplication, right? Notice we never have any addition in here. But not 2 plus x to the 4th. That would not be 2 to the 4th plus x to the 4th. Okay, so this is going to be 16x to the 4. Over here, I'm going to just multiply all of these exponents by 3/4. So x to the 8 times 3 over 4 divided by y to the 4 times 3/4. And, all right, that'll be 8 times 3 is 24, divided by 4 is 6, and 12 divided by 4 is 3. So x to the 6 over y to the 3. And there's not going to be anything else we can do with that because of, x and y being different. Right. Negative 64 to the 1/3 is going to be the cube root of negative 64, which is the cube root of 64 times the cube root of negative 1. The cube root of 64 is going to be 4, and the cube root of negative 1, that's just negative 1, right? Because I can take negative 1 to the 3rd power and get negative 1. So 4 times negative 1, that's going to be negative 4. Now if I'm taking these things to the 1/3 power, that's the cube root of each of them. 25. And the cube root of x to the 3, well, I'm just going to divide the exponent by 3, and I'm just going to get x to the first. Over there, if I'm taking the cube root of 1 over 125, I could say that, hey, that's the cube root of 1 divided by the cube root of 125. Cube root of 1 is going to be 1, and the cube root of 125 is 5. And so I just have 1/5 of x. These, I don't know, maybe I'll do this one with a negative exponent a little bit differently. So I'll just multiply in the exponent, right? Because if we're taking power of a power, it's where we multiply the exponents. Negative 1/4 of 4 is negative 1, and negative 1/4 of 8 is negative 2. So if I have a to the negative 1, that's 1 over a. B to the negative 2 is 1 over b squared. So I'm going to say that's 1 over ab squared. Right? I think we did one like this, a ways back, but I'm just going to work these, like kind of multiply in the exponents and then combine stuff afterwards. Although, actually, I don't think that's going to be the way to go. Notice we've got 3x on both of these. We've got the kind of the same base, different exponents. That's where we should add the exponents. So I'm going to say that this is equal to 3x taken to the 2/3 plus 7/3. Yeah, that'll be the way to go. Because otherwise we would have had these bad fraction exponent powers of 3 and x, and we would have eventually had to combine them like this anyway, so we might as well do it now. Okay, so this is going to be 3x taken to the 9/3, which is 3. And then 3x cubed is going to be 3 to the 3rd times x to the 3rd. This next one, if I take the cube root of negative 8 and the cube root of x to the 9, and then square it. Split it up like that. The cube root of negative 8 is negative 2, and the cube root of x to the 9 is going to be x to the 3. And then if I square that, I'll be squaring negative 2, and I'll get positive 4. I'll be squaring x to the 3. I'll be getting x to the 6. I'll be ready to move on. I'm taking this whole thing to the negative 1/4 power, but maybe I should simplify on the inside first, because I'm seeing, like m to the 8 over m to the 12. And I know that's something I can work with, right? I can say that's m to the 8 minus 12. Still taking that to the negative 1/4 power. Yeah, I like where this is going, because then I'm going to say that this is m to the negative 4 to the negative 1/4 power. We're going to multiply those exponents, so negative 1 times negative 1, or negative 4 times negative 1/4 is going to be positive 1. So it's just m to the first. Alright, now finally, after a bunch of them, we've got one where we're going to have to do like a little bit of simplified radical form stuff. So 24x to the 5th over y to the 10th square root. Okay. So I'm going to take the square root of 24, I'm going to take the square root of x to the 5th, and I'm going to take the square root of y to the 10. The square root of y to the 10, that'll probably be the easiest, is dividing the power in half. So it'll be y to the 5 in the denominator. Okay, the square root of x to the 5 is going to be x to the 5 halves. I don't think there's anything wrong with writing it as a fraction exponent. I think that's simplified. But the square root of 24, that's something I'm going to have to do a little bit of work with. Okay, so I got to think of numbers that divide 24 that are kind of on my list of square numbers, like 1, 4, 9, 16, 25. 25 is obviously too big, so I think the only one I've got in there is 4. So I've got the square root of 6 times the square root of 4. The square root of 4 is the one I know, so that's 2 root 6. So I'm going to say that this is 2 root 6 x to the 5 halves over y to the 5. 16 squared divided by 16 to the 5/4. Well, I'm going to subtract those exponents, since I'm dividing two things with the same base and different exponents. Let's see, I've got, looking to subtract these two fractions, so I'm going to need a common denominator. 2 over 1, I can write that as 8 over 4. Right, so 16 to the 8/4 minus 5/4 would be 16 to the 3/4. So that's going to be the 4th root of 16 taken to the 3rd power. 4th root of 16 is 2, and so I've got 8 here. Now, yeah, I wouldn't recommend doing 16 squared is, I think, 256, and 16 to the 5/4 is 32, and actually dividing those, you could do that, if you're really good at big number arithmetic, but I think this is the way to go, right, to keep the numbers more manageable. Just like this one, you could say that this is 36 cubed, taking the square root of. I just don't know what 36 to the 3rd power is, and I don't expect you to either. Okay, the better way to go here is to take the square root first, and then take that to the 3rd power. Okay, so I'm going to take 6 to the 3rd. This was one of the very first ones on this homework. It was that 6 to the 3rd is going to be 216. But we're not even done yet. I thought that was going to be it. Alright, so something's cube root taken to the 9th power. Well, we would multiply that exponent by 3. And the cube root, remember, that's the 1/3 exponent. So I'm taking that to the 9th power. I would multiply those and have the 3rd power of 7x. Okay, so that'd be 7 to the 3rd times x to the 3rd. Oh, 7 to the 3rd. Alright, well, 7 to the 2 is 49. Okay, so this would be almost 50 times 7. So it would be 350 minus 7, right? Because I'm just missing one of those 7s to get 57s. And I'd get 343. I don't know, maybe you've got a better way of knowing what 7 to the 3rd is, but just need to remind myself. Okay. B is square root of 16 is 4. Square root of x to the 6 is going to be x to the 3rd. Square root of y to the 3, 3 doesn't divide in half cleanly, so I'm just going to call that y to the 3 halves. And z squared square root, okay, in the big picture, that's the absolute value of z. Okay, so you can say the same thing about the square root of x to the 6. That's the absolute value of 4x to the 3rd. But they said at the very beginning of this problem set that we just assume the variables are positive. So we're just going to say that's z to the 1st. This one, maybe I'll show you a different way of thinking about this one. I haven't done that yet in this video. I know that I'm going to have to add these exponents together, but I've got a fraction and a whole number and 5 halves. That's the type of number you should be pretty good at working with, just from experience. I'm going to say this 25 to the 2.5 power times 25 to the negative 2. And then, I'll add those together. 2.5 minus 2 is going to be 0.5. And the 0.5 power, that's half. That's the square root. And that's equal to 5. So that's just another way of thinking about that one, if you like that. Alright, now the last set of problems is just put these in simplified radical form. So this is kind of what I was saying at the beginning. No unsimplified radicals. So it's like if there's a square factor of the number, then we're going to have to, kind of factor it out and simplify that square root. And no radicals in the denominator. So we should probably be able to do that. Alright, square root of 500. So I'm thinking about, really, I might even put these up at the top for a second. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, really, I don't think I would ask you to look for where things are divisible by 121, but I'll just throw these out there as well, because it's kind of our, knowing our times tables, knowing our square numbers is up to 144. But there are certain other squares that we should know, like 20 to the 2 is going to be 400, 30 to the 2 is going to be 900. I'm trying to think what else. One that I found useful is 100 to the 2 is 10,000. But that's a different discussion. Okay, here at 500, that's going to be divisible by 100, so I'm going to say, hey, that's the square root of 100 times the square root of 5. And then that's going to be 10 root 5. square root of 444. Okay, I see it's divisible by 4. I don't know if there's anything else, so I'm just going to say square root of 4 times the square root of 111. Okay. It's 2, and 111 is going to be divisible by 3. What would that even be? It's less than 40. Maybe 37? Yeah. 3 times 37 is 111. 37 is a prime number. 3, there's none. Can't take the square root of that. So that's as far as I can go with that one. Right. Square root of 216. Well, okay. 216 is 36 times 6. So I'm going to say square root of 36 times the square root of 6, and I'm only remembering that because I've had to do it twice on this homework. So I've got the square root of 36, that's 6. Square root of 6, I don't know what that is, so I just leave it like that. 6 root 6. And then here, okay, good, we've got one where we're going to have to rationalize the denominator. So we want no denominator in the square root, so we're going to multiply by a clever form of 1. And the form of 1 we're going to multiply by is root 3 over root 3. And then we're going to remember that root 3 times root 3 is equal to 3. I have 1 times the square root of 3. So I've got root 3 over 3. And hopefully you did that enough last year that you kind of just remember that 1 over root 3 is the same as root 3 over 3. 2 over the square root of 8. Now, this one, you can simplify the square root of 8 kind of like ahead of time, but that's not actually, I don't think, what I recommend doing. Let me think about this. Yeah, I think that you should simplify it and then rationalize. I'm going to just rationalize first, because that should be the first thing you notice about this, is that, they want you to multiply by root 8 over root 8. And so I've got 2 root 8 over 8. Okay, but yeah, probably what I'll do is I'll recommend that you simplify the radical before simplifying like any sort of fraction stuff, because there's going to be more 2's coming out of that square root of 8, right? Because the square root of 8, that's 4 times 2, so that's going to be equal to 2 times the square root of 4 times the square root of 2, all divided by 8. And the square root of 4 is 2. So I've got 2 times 2 is 4, root 2 divided by 8. And 4 divided by 8, that's like 1/2, so I've got root 2 over 2. The square root of 9/14, that's going to be the square root of 9 divided by the square root of 14. And so that would be 3 over the square root of 14, but we don't like the radical in the denominator, so we're going to multiply by root 14 over root 14. And we'll remember, okay, that's going to be just 14 in the denominator. I'll have 3 square root of 14 divided by 14. And that root 14, there's not going to be anything I can do to simplify it. I'm talking about that one right there. Because 14, that's just 7 times 2, and neither 7 nor 2 are perfect square numbers, so that's all I'm going to be able to do to simplify that. Here's a couple that are a little trickier. Okay, so G has got a cube root in it, and H has got an irrational number that's not just a square root of a number that's not a perfect square. So with G, I'm going to go over here. I'm going to say, all right, what I need to do is multiply by a clever form of 1. And hopefully I showed you how to do this in the video or in the lesson in class. But I need to get a rational number in the denominator. So I'm hoping to get 4 in the denominator. But I need 3 cube roots of 4 to get 4, right? So I'm going to have to multiply by the cube root of 4 twice. So on the denominator, I have 3 cube roots of 4, which would multiply together to just make 4. But I don't want to change the fraction, so I just have to multiply by 1 twice. Okay, and so in the denominator here, I'm going to get 4. I'll have 3 times the cube root of 4 times the cube root of 4. Now you got a couple of options here. You could say that's 4 to the 2/3, but I think the most common thing to do is to say that's the cube root of 4 times 4, which is 16. And that would be simplified radical form for that one. And then H, okay, No, we didn't. We didn't have cause to do this in a previous unit, but we did something very similar. We used the radical conjugate. So we say, okay, if we have 2 plus square root 5, and we want to get a rational number in the denominator, we're going to multiply by 2 minus square root of 5. But in order to not change the fraction, I have to multiply by 1, so I'm going to multiply by the same thing on top and bottom. So I'm just finding the conjugate. And then I'm going to, okay, just have 2 minus the square root of 5 on top. But on the bottom, I'm going to have to do, like FOIL. So I'm going to have the first 2, oh, pardon me, first 2 is 2 times 2 is 4. The outside 2 is minus 2 root 5. The inside 2 is plus 2 root 5. And remember, that always happens when we're multiplying radical by, a plus the square root of b times a minus the square root of b. Kind of like when we're multiplying a complex number by its conjugate. And then the last 2 I'll have positive root 5 times negative root 5 is minus 5. And what always ends up happening is, these things with the square root in them are going to cancel off, so I have just, integer in the denominator. I have 2 minus the square root of 5 divided by 4 minus 5. And so, okay, if I'm dividing this whole thing by negative 1, I'd just be changing the sign on each of these things, so I get negative 2 plus the square root of 5. And the fact that 1 over 2 plus the square root of 5 ended up being negative 2 plus the square root of 5 is... That's just a coincidence. That's not something, that's going to be true in general. I think it's mostly because of the fact that, 2 squared minus the square root of 5 squared happened to be negative 1. That was coincidental. But what do you know? That's the end of the homework. So that's going to be all for this video. Thanks for watching.